Find the domain of each function. All right, for example A, we have to find the domain for the function ln of x plus 7. So it's important to remember that a log asks the question, what power do you raise the base to in order to get whatever value they're talking about? So it's not possible when you're dealing with an exponent, right? So for example, if you have 2 to the x, it's not possible for this exponent to make this 2 to the x be 0 or negative. It can't be. Nothing you can raise 2 to is ever going to make it negative, and nothing you could raise 2 to is ever going to make it 0, right? It's not possible. So basically, that means that you cannot take the log of 0 values or negative values. So remember that we have a new restriction on the domain now that we didn't have before. We used to only worry about fractions or radicals. Now we have to worry about logarithms as well, and we have to know that the inside of the log, in other words, this piece here, it must always be greater than 0. So it can't be 0 and it can't be negative. So if that's the case, we're saying that in order to determine the domain for this function, we have to show that x plus 7 is always greater than 0. And if that's the case, then that must mean that x must be greater than, well, if I move this 7 to the other side, it becomes negative 7. So as long as x is greater than negative 7, we'll be fine, right? It cannot be negative 7, because if it was negative 7, 7 plus negative 7 would give you 0, and you cannot take the log of 0. So the domain for this function is very simply from negative 7 up to positive infinity. And we'll round both of those because we want to say that we were not including negative 7, nor obviously can we include the concept of positive infinity. All right, so let's do the same thing for example B. We're going to be looking at this x to the 4th. This one we might have to be a little bit more careful. No matter what I put into x to the 4th, whether it be negative or positive to start, once I raise it to the 4th power, it's going to be positive. So I'd basically say that any number that we put in for x to the 4th is going to be positive after you take it to the 4th power. And only then would you take the logarithm of it, right? So it would seem that we don't have to worry about negative values. The only problem number would be the number 0. We can't put 0 into the function because if you take the 4th power of 0, you still get 0, right? I mean, clearly we don't have to worry about something like negative 1, right? Negative 1 normally is not allowed in a log, but if you did the log of negative 1 to the 4th power, the 4th power would kick in first, making it just positive 1, and you end up taking the log of 1, and that's okay. You'd end up getting an answer. In this particular case, you'd get the answer 0. But the point is you can take the log of something that's raised to the 4th power, no matter what the sign of that something is, because of course, once you raise it to the 4th power, it's going to become positive. The only problem value here would be 0, I think, right? Because even if you raise 0 to the 4th power, you still get 0. And so if I take the log of 0 to the 4th power, it's the same as taking the log of 0, and that's a problem, right? Because this is not defined. We can't answer that. All right, so for us, we're going to say the domain is from negative infinity up to 0. Round bracket on both of those, union from 0 to positive infinity, because we want to leave out 0, right? We want to make sure 0 is excluded from the set. But all the other numbers will be okay. So that's our domain for B. All right, let's take a look at example C. So in example C, again, we have a lot going on in the function, but we don't care about any of that. We really only care about this piece here. That's the only part that has something that's of concern to us. We want to make sure that that quantity inside the logarithm is always greater than 0, right? So it'll be x over 3 minus 7 must be greater than 0. So what does that say about x? Well, if we add 7 to both sides, we end up with x divided by 3 is greater than 7. And then from there, we multiply both sides by 3. So multiply each piece by 3 here. The 3's cancel out. You end up having the statement that x is greater than 21. So our answer is that our x values must be greater than 21. So that means we'll go from 21 to positive infinity, round parenthesis on both of those because we do not want to include 21. All right, let's look at example D then. For this one, we have a similar issue. We want to make sure that this piece inside the logarithm is always greater than 0, right? So we're looking to make sure that x over x minus 2 is greater than 0. So we have essentially a rational inequality. We also want to make sure that we don't put 2 into the function. Obviously, we can tell that if we put 2 in, it'll have in that fraction 2 minus 2 in the denominator. And that would be undefined, so we wouldn't be able to do that either. So let's go ahead and solve this rational inequality. Remember how you do that. You basically have to find the numerator set equal to 0 and the denominator set equal to 0. And then we're going to use those as test points, right? So if we set the numerator equal to 0, we get x equals to 0. We set the denominator equal to 0, we get x minus 2 is equal to 0. So therefore, x must be equal to 2. All right, so these are the points that we're going to use to divide up our number line, so to speak, right? And we'll have here x is equal to 0 and then x is equal to 2 on the number line. And we're going to test regions, right? So we can test here, which is -1. We can test here. Maybe we can test +1 here. And we can test here something like 3, right? So we're just testing numbers in the region. And what we're looking for is to find the areas where the answer is greater than 0, right? Okay, so let's talk about if we test -1. What happens if you put -1 into this fraction? Well, you end up with -1 over -3, and that's the same as 1/3, right? Because the negatives cancel out. So this is good, and this is a good answer. So we're going to shade this area as saying that's a good part of the solution, right? Let's test the value 1. If I put 1 in the fraction, I have 1 over 1 minus 2, which is going to give you 1 over -1, which is -1. That's not greater than 0, so this area won't work. So we'll call this false, basically, or an area where our inequality doesn't hold. All right. And let's lastly check 3. We're going to test 3 now. So we'll put 3 in there. It'll be 3 over 3 minus 2. And of course, that's going to give you 3 over 1, or 3. But 3 is positive. That's all we care about. So that means that this area is good as well. So we have two regions where we can use our values. And basically, the domain for the function will then come from those regions. So it looks like from -infinity up to 0. Round bracket on both of those. Then union, we're going to start at 2. And go up to +infinity, again not including 2, and we cannot include 0. All right, so there's our domain for the last one.